Hey guys. Hello. So tonight I am assembling fingers. Like doing the circlips and everything. Spent most of today making a box full of pins. And it went pretty good. Pins just take forever to make. But I got them. And let's see, something that's interesting. This weekend, one of the guys that I'm building a hand for is going to be coming to the shop for the weekend, and we're going to try to put most of one together for him. Still got to come up with the Gaffney plate and the gimbal, because I've never actually met him in real life, so I don't know really the characteristics of his hand. But should be awesome. So the way this works is the pins that I made earlier today, or I should say all day today, they have, okay, so the pins that I make have a little groove in the center of them. There are 6 different sizes of pins for it, and all of these pieces have a little groove in the center of it, and that's where a circlip goes. And what that, that of course just keeps the pins from traveling left and right. It's the cleanest way that I've found of doing that, of locking and indexing the pin. So, kind of cool. So, and then I have this special tool that I made that it helps me to push down just right on the back of the circlip. What up, Juju Win? So that lets me push down just right on the center back of the circlip. And if everything goes correct. No, putting the other prosthetic fingers. I'll show you in a second. Let me get this circlip for the distal link in. I will show you. All right. Oh, where is my hand? Well, shoot. Let's go up to the front of the shop and grab my current one, and then I'll show you what I'm working on now. So I've been working on this for, I don't know, 7 years now. I ended up losing my fingers after an autologous stem cell transplant and super low bone density. And then I didn't have an immune system after that, and I broke my fingers. So this is my current hand. I do. When I'm working on little tiny stuff, it doesn't work. Like those pins are 3/32, so 0.95 diameter. So when I'm working on super tiny stuff like that, it doesn't work amazing. But just for like regular stuff, it works really good. All right, so this is my normal hand. The finger splay, and so, and today I am putting together the individual fingers. Awesome. So, like I was saying, one of the guys that I'm building a hand for is coming out this weekend, all the way from Georgia. So I'm going to try to have him most of a device put together. What up, Brandon? In fact, that's Brandon right there. So right now I am building Brandon some fingers. I spent all day making pins and filing things. Okay, so the problem with embedded neodymium magnets, I work in a metal shop, so magnets would stick to everything. And that gets super old. Okay, and this pin is held in with this little traction piece right here. So no circlip on that one, but circlips on all the rest of them. Oh yeah, no. No, and supposedly, if you do the embedded magnet thing, then you can start sensing. You can sense voltage. You can sense AC voltage. And I mean, that sounds cool. But like for me, where I'm immunocompromised because of the multiple myeloma, I would be afraid of getting encapsulation sickness to where where my body makes a capsule around the magnet, and then I end up getting sepsis. That's what I'd be worried about. Considering I already did the whole sepsis and gangrene thing, and that sucked. Let's see. Okay. But yeah, I don't know. I thought the idea of the body mod stuff was cool. It's just I don't know if I'd want to risk the infection. And then also, what happens? There are a couple people that I've talked to that have done the whole embedded thing. And what they found is that the magnets shatter. And then when that happens, then you just have little tiny pieces of magnet embedded into your, embedded in your hand. And that sucks. So this finger is mostly put together. I got to put one of the T's in it, and then a spring. Here's one of the little T's. This one a bit. Put circlips in one of these. Let's see. Oh, circlips are in this one. All right. Yeah. Well, and then, you can't really get all of the parts out. That's the real bummer about it. You'll have, just parts of magnets stuck in you. And then you'll get sepsis, and then you end up getting cut on, and, that's a bad deal. No, it's the whole having a foreign body stuck in your skin that becomes the problem. Okay, this needs to be just a little bit shorter. I don't remember that being like that, but evidently on this one it does. Okay, so that's... Okay. So we're doing a medial. Right. Well, because, if it's always pulling against something, I mean, it's like when a kid, swallows a magnet, and then, two magnets end up sticking together, sticking to each other in, like, their intestines, and then it ends up forming a blockage, and then you end up getting necrosis and just bad, all for party trick. All right. All right. So there it is. This is Brandon's gonna be pinky. So now we're going to do his middle finger. Need another one of those T's. All right. Well, right now for Brandon's build, we're doing a 3-finger build. His hand, after the revision surgery, ended up closing up on some of the width. So, or at least that's the plan. If when he gets here, it looks like he can actually do 4 fingers, then I'll change his gear to be in 4 fingers. And we'll see how that goes. But I think we decided that that he was going to roll with a... Oh, that's too small. That's a 2mm. Need a 3mm. Yeah. Yep. I mean, the whole magnet thing is cool on the surface. I just don't know what the long term would be. You know, and then trying to have them removed. You know, because I mean, you could get some really good attachments, some fibrosis, you know, and then you end up, needing to remove actual parts of your fingers or wherever you're doing the magnets. All right, so that is, you know, we should probably just start at the beginning. Okay, so we got that one. Yeah, I saw somebody was selling coated magnets, you know, magnets that have supposedly a biocompatible coating on them, you know, to where you, in theory, wouldn't have as much rejection. But I don't know. I mean, the thing is, you'd have to have something that you'd actually use it for to make it worth doing that. You know, it's like, the people that do the embedded RFID, you know, an RFID chip. You know, that's cool, but, you know, you need to have something in your life that, you know, is RFID that you use all the time. Say if you're replacing like a key or something. But I don't know. I wouldn't be super on board with doing that. All right. Right. Well, because you got to figure anything, you know, anything that you put in your body is looked at as a foreign body. You know, so your body's going to start rejecting it. You know, you're going to have B and T cells that are looking at it as being the enemy, you know, no matter what. You know, and that could be bad. I don't know. I mean, for my situation where, you know, immunocompromised and all that, I wouldn't risk it. All right. Next pin. I gotta find the print file for the proximal 1 bushings somewhere. Probably print those out tomorrow. And then that'll lock. Yeah. No, that's... I don't know. That's pretty gross. That's pretty gross. Oop. That didn't take. All right. Ah. Okay, maybe we got to do a 2mm circlip for that one. I am the guy with the cool hand. Okay, so I got to do the tiny ones for that one. Yeah, I mean, like, the one that I don't get is the people that do osseointegration, where they actually have the pin, the socket pin actually go into, like, their femur. You know, and you look at that, and that is just crazy. You know, because when it rejects, you know, the center of your femur or whatever is essentially rotten, you know, and the pin, you know, ends up falling out of the bone. I mean, that would just be terrifying. All right, I gotta get a spring. I'll be right back. Okay, got my handful of springs. And that way I can lock the spring tee in. Right on, Simon. Good night. All right. So that has 2 there. And I got those 2 in. So now it's just, I got to get the medial in there. All right. Okay, so this one goes to the distal. This one goes to the medial. No, that doesn't go there. This one goes to the bottom of the medial. Oh, yeah, no, I have a whole box of springs. Have a whole box of springs. I guess that one actually goes there. Boy, that just doesn't look like it does. It looks like it's just a skosh too long. Maybe this one. There's only like 20 thousandths difference in the length of the pins. All right. I'm going to pull one from the box and see Okay, so that's a good one. Let's see what circlip that one takes. There's two different sizes of circlip. I run a 3mm and a 2mm, and depending upon how I end up... Yes. Yes, I do AutoCAD. Okay, so that one's in. Let's do a distal. Yeah, so all my parts are on AutoCAD. Right? No, I mean, insurance companies sucked. That was Regents Blue Cross Blue Shield at the time. They were my insurance carrier. And they were like, fingers are considered a luxury. All right. All right, so we have 2 fingers for Brandon. I still have to make him a winder. I thought that I had ordered his winder, but evidently I did not, which sucks. Oh yeah, no, it's I don't know. Insurance companies suck. Yeah, well, they were just, it's not medically necessary to have, to have hands. All right, so I need to put a piece of chain of some sort into this one. So this is the double wiffle tree, but for Brandon, we're not doing that. We're doing... I just need just a piece of chain. Need a chunk of chain. Well, that is made up wiffle trees. All right, so I got a chunk of chain. Well, I would imagine that it would hurt. You know, if nothing more, it's going to hurt, you know, your hand where the socket interface is. Alright, so I need to take just the point off of that. No, I have too much hand to make a pirate hook. All right. Let's see if that's the right length. Because these pins have to be like exactly the right length. There's no room. There's no room on the inside of it to be. No, so originally on the project, I was doing the electronics, and it just wasn't durable enough. You know, batteries die. You know, when you sweat, the interface doesn't work. I mean, I had so many reliability issues when I was doing the electronics. You know, and then also, okay, so say you're going to do a thermocouple. You know, what do you do for your interface? So, you know, you could do, cell phone vibrator motors. You know, but then you still have to interpret it, you know, from the rate of the vibration to a temperature. You know, I ended up just seeing just way too many problems with it. You know, and that's why I've just stuck with the electronics, or, you know, just stuck with it being mechanical. You know, because mechanical doesn't care if it gets. So I did that back with like 157. 157 was a myomechanical, to where I was using I was doing 4 EEG sensors, doing, and they were sensing the interossei muscles in between your metacarpals. And I couldn't get a good enough signal definition that I could reliably operate it. And, you know, and then it was just so slow, you know, because you got to figure every time, you know, every whatever of second, depending upon how big your language model is, you know, it has to run through the entire language model every time, you know, and that runs all the time. You know, so you end up just burning a pile of compute cycles. I mean, that's what sucks about, you know, the myoelectric devices that are available on the market right now. You know, it takes 1 second to open and 1 second to close. You know, and they're incredibly fragile. And that's what I absolutely hated about. Yeah, so okay. So you're going to do, multi-core. So I was doing uh dual core ESP32s is what I when I was doing the electronics. And um it's still slow. I mean, it's just slow. And it has to be because the diameter of the motor, uh, and the amount of amperage that you're able to push through the circuit, and then you'd be having to, if you increase the amperage, then you got to be packing around bigger batteries, and then your, larger motor drive circuits, and it you end up just chasing your tail on that. And then you're dealing with the heating issue because now you're pushing more amperage through it. I mean, electronics are cool and all, but for the durability, they just aren't it. All right. Now let's do a tiny one. Oh yeah. No, I remember. What was it? It was one of the Maker Fairs before Bay Area shut down. Before Maker Fair Bay Area shut down. Um, I brought one of my electric hands, and it was raining just a little bit, and because I was sweating and it was raining, I was using FSRs as my signal generator, and I had the absolute worst luck with it. And as soon as an FSR, gets contaminated. All right. And another one. What's easy? Okay. And we'll do a distal. Why on earth would I ban you? What up, Mr. Ray? How are you? Oh, I only got 5% on battery. I better switch to... There we go. Let's see. I need to be over there, but I need to be over here too. Okay. I'm just going to move everything over here so I can charge my phone at the same time. Let's see. Okay, so that goes to that one. This one goes to this one. Yeah, I was needing to save. I was needing to make more money. That's why I took the time off of doing videos, because really lately I haven't been making anything money-wise off of YouTube. You know, and that's hard. Oh, yeah. I've thought about that, but the thing is, okay, so if I go in and make a Pip-Boy or something like that, okay, so I'm gonna have, say, $100, designing this thing that has no real purpose. Okay, so it has no real use. And then if the video doesn't do very well, I'm gonna make like, $10 off of it. Anything that's super tiny is what I end up having issues with. Pretty good. All right, let's finish deleting some videos. Okay, and I did... Okay, so 36 through 3904. 36 through 3904, and we can delete those. Doing good. Right now I'm putting together the parts for Brandon's hand, because he is going to come out and see me this weekend. So super excited about that. We're going to do a 3-finger device for him. And hopefully that works out really good for him. All right, so we got... Well, we're only going to end up using one of those. No, a patent is only as good as the dollars you have to protect it. And if you aren't willing to write a six-figure check to protect it, don't write a five-figure check to get the patent. But saying that, I'm not just going to, give away my design for free. Yeah, but okay, so back on the Pip-Boy thing, you're going to end up having, a zillion hours in time on that. And it's for a gimmicky thing that, doesn't really serve a purpose. All right, so this, that's the thing about, YouTube. Just because you put, so like the video that I put out today, it's 12 minutes, okay? I have probably 25 hours in that video. By the time you write the script and shoot the video, then edit it, and then shoot all your B-roll, you have a bunch of time on that. So same thing with if I were to, try to do like a Pip-Boy or something. So, to answer your question there, I think it says Gilfor. No, people don't like, giving up the money for free to go and fund things like this. Getting funding is incredibly hard. Because nobody wants to give up the free money. I mean, okay, I've been live for 48 minutes, and I have $0 in my, live total. So yeah, no, people don't, it's tough out there right now. People aren't into just giving away money. Yep, and that's the story for everybody. I don't know, a couple times I answer your questions. I talk to you directly. So what should I do that would be worthy of a donation on my live? Hey, time is money. I mean, I charge $150 an hour at my machine shop. Yeah, man. I am literally building Brandon a hand. Dude, no way, Raid. You totally didn't have to do that, man. But thank you. I do appreciate that. Or Reed. This is going to be a prosthetic hand for Brandon, the guy that was in here earlier at the very beginning. This is his hand. I am building Brandon a hand right now. I mean, the reason why I'm able to do that is because I got you know, a grant from OSV last year, and that went to go and fund a portion of what I'm doing right now. Man, that's really awesome. That is really awesome, Reed. Thank you. I will put that to some good use. No, I appreciate that. That's awesome. That is super awesome. Well, thank you, Fuzzy Pickles. That's super cool of you guys. So what I do with this money is, so like there's a kid, Alex, that he works at the Carl's Jr. And if you look back in my videos, you'll see that I made him a glommer, basically a couple, what was last year? I made him a glommer, and I fixed his, he has a bifurcated fork, you know, a regular, a pincher hook, and it was all kinds of broken. I ended up fixing that for him. And of course, I didn't charge. You know, I don't charge my people for that. You know, which is cool. So, let's get some anchor plates and turn on this light above me. Okay, so we need a right hand. We need a right hand anchor plate. Those are left-handed anchor plates. Nope. Yep. Yep. All right, so these are going to be Brandon's anchor plates. So, and one of the things I changed on this last build, I changed from it being a keter on the top and the bottom to being a circle on the bottom. And what that does is it gives me better interface for the splay to where I don't have, boy, you're getting a heck of a glare. All right, we'll lose that light. Is that better? That's better. All right, so these are going to be Brandon's anchor plates. And what they do is they go top and bottom like this. And then the Gaffney plate, which let's see. So this is what his winder looks like. I went and I printed it in resin on my Saturn printer the other day. I'm gonna need to wow, I'm thinking I'm missing some of this conversation. All right. I'm going to go grab my other phone. Oh, maybe I'm not going to grab my other phone. It's still down to like no percent. Well, thank you. I appreciate that. It is a lot of work. I mean, you got to figure, I end up having literally thousands of hours on these things. Well, did it? Did it freeze? Okay, I'm going to go grab my other phone and see what's going on. Hold up. All right, got my other phone. Let's see if my freezes. All right, Ian Davis. That looks like me. That looks like me. All right, cool. That looks like me. Okay, I'll turn that down. All right. All right, cool. All right, so I'm going to be machining these out of aluminum tomorrow. Okay, so yes and no. So right now I am doing 3 and 4 finger builds. Actually, I should take that back. I'm doing left-handed. So, do you remember Chris, the guy that he ended up coming in like December? So this is his winder, and this is a normal 4-fingered winder. So yeah, I had to customize this to end up working for his situation. Like the fingers are actually such a small part of the prosthetic device. People get all kinds of excited about, the fingers themselves, but really, so last time I counted, it takes like 290 parts to build to build up this. So the fingers, you know, that's only a small part. And while some of the things you can reuse, like the index and the ring, those are the same finger. You know, those are the same dimensional piece. And the Gaffney, it's close, but that actually varies depending upon the length from the end of the residual limb to where the wrist rotates through its center point. So, you know, this has a double eccentric in it to allow you basically 10 millimeters forward and back and up and down worth of total adjustment. But like for Brandon's setup, you know, I wouldn't be surprised if I end up having to make a custom one of these and shorten it. I know that with Chris, he's going to be coming back out, I don't know, in probably a month or so. You know, whenever he gets time off from work, he's going to come back out. And I'm going to try to do the same thing that I'm doing for Brandon right now and have a device mostly built for him when he shows up. So I guess the long and the short is, you know, you try as much as you can on the fingers to have them be standardized, but you still end up making some customization to it. You know, it's like, you know, my hand isn't the same size as your hand. Hope that helps. So like on this batch of stuff, I ordered 12 sets of fingers. And just the fingers was a little over $5,000. And then I got hit with an $1,800 tariff. So the whole thing ended up being $7,000 for the fingers. Which sucked. But it is what it is. So, you know, and there's only certain geometries that'll work. It's like I can't make the fingers any more narrow. Just because of the limitations of SLS printing. So these are selective laser sintering in mag aluminum. Oh, totally. Yeah, I mean, like I said, if I were to have ordered them right now, you know, I would have what is it, $7,400 worth of tariff. And I mean, and that's insane. You know, especially since, you know, I'm essentially self-funding this, you know, between Patreon and the OSV money. That's how I'm funding this. You know, and I mean, I don't make hardly anything on YouTube, really. I used to make money on YouTube, but that's changed. Oh yeah, no, so I don't take insurance. You know, it is a direct pay. You know, like when say if I don't have any money in my Patreon, you know, and I end up charging somebody, you know, they're paying me directly, you know, because I'm not a licensed clinician. I'm not a prosthetist. So, you know, I can't charge, I would be charging as a machinist. So I'm aiming for one of my prosthetic hands to be like right around $20,000. So, and that sounds like a lot, but it really isn't. Thanks. I appreciate that. Right, but okay, so like my myoelectric hand, it was invoiced to my insurance company at $85,000. And it, a lot of it is the insurance racket. I mean, okay, so I mean, don't get me wrong. I love my insurance company because they afford me to go through chemo 1 day a month, every month. But that one treatment is now like $67,000 every Tuesday that I go. And there's, I don't know. I mean, insurance is a racket, especially like where I am. I can't really live without insurance. Yeah, but where I'm not doing it as through a clinic. If I was doing it through a clinic, then I could, but then you have to have a class code for the insurance to accept the billing for. And unfortunately, insurance companies don't want to pay for things like this because it's viewed as a prototype. Well, every hand, everybody's hand is different. So each hand that gets built would be a prototype. And that's the tough thing about insurance. I mean, insurance just sucks. But yeah, no, I mean, at 20 grand, I'm eating all of the development cost. Because I mean, in reality, I'm not going to sell, I won't sell 100 of these during its entire lifespan of the project. And really it's because of OSV and that type of thing that it even allows me to okay, so if I were to do the FDA, so get it approved through FDA, it costs $88,000 to prepare the paperwork in order to submit it to the FDA. And then for me to do all of the filing fees and all of that, it's going to cost $2.3 million. So you're going to be, you're going to be 2.4 basically, $2.4 million before you've sold one. Before you can legally sell one through a clinic. And then you still have to get somebody that, their insurance will buy it. Just because you have it available in clinic doesn't mean you're going to sell any of them. Because I mean, really, if somebody's insurance would buy it, your clinician can request a device from me, and then I can build it. And then they can certify it as, a medical device. That's the cool thing about, clinicians and stuff. They have this ability, through basically a loophole that they can go, yep, this is a device. This is a medical device. But all of the inquiries need to come from them to me. I can't I can't advertise from me to them, because then I would be offering a mechanical device. I would be essentially manufacturing a medical device without proper licensure or clinic. And that comes with a $100,000 fine per occurrence and 10 years in federal prison for manufacturing without a license. And yet, a clinician can go, hey, I need you to build me something like this. And it would be perfectly legal. Yeah, I don't think I would have a problem keeping up with the demand. You got to figure this is actually for a very specific amputation. It's for disarticulation at the metacarpal level with no retention of the proximals. And so, there's a lot of things that, the stars have to align. The person has to be in the right, stage of healing. They have to want to have this aesthetic, this kind of, steampunk aesthetic. And they got to be, their insurance has to be able to fund it. Because otherwise you're gonna accept whatever your insurance is saying that they'll pay for you. Yeah, and that's where you get all of the payoffs and that type of thing, on the insurance side of thing, to where you have, people paying off doctors to, oh, we only build OSER things. We only build Autobach things. It's all a racket, but that's how they end up doing it. And it's terrible to say it that way, but really that's what it is. No, because of the way the mechanics are on this, you're driving it with the wrist. So like, if you had your proximals, so if you had this part of your finger, then it wouldn't be this same device. You'd be doing an MPC driver, to where you'd have an anchor point on the back of your hand, and when you move the proximal, then that would cause the medial and distal to articulate. So there are other designs for other levels of amputation. And, say if it was a disarticulation, through the metacarpals, say it was somebody that lost their hand through here, there isn't enough of a lever to drive the fingers. You need essentially 4 inches worth of lever here in order to generate enough force to where the fingers are actually usable. This one's fine. It's got a couple things that I don't like. I described that in the video that I put out today. I don't like. So for right now, I'm getting rid of grip pattern selection. And that's just because it isn't reliable and robust enough for me to feel comfortable having somebody else rely on it as their daily device. And then, like what the video says, I don't like the aesthetic of the driver link being outside of the Gaffney plate. So those are 2 things that are going to change. But aside from that, the winder is still good. The Gaffney minus grip pattern selection is good. And I use it, I use it every day in metal fabrication and in a metal shop. So that's pretty cool. Thanks. Yeah, so I mean, if you've seen the video of me running a grinder with it, deslagging parts, I mean, it works good, in that type of work environment. And that's tough. I mean, like an oh sir, I just, like a quantum, one of the Myo devices, it wouldn't survive in a shop condition like what I normally run in. It just wouldn't survive. Oh yeah. No, I mean, like and the tough thing about that is, you about have to have the insurance for that device. And that's like $300 a month for insurance, for when you break your OSER iDigits Quantum. And then they only do so many breakages a year. It's like you can break 2 fingers a year and that's about it. But if you didn't have the insurance, the fingers are $6,000, each. And a lot of that is because they're running it through insurance. So what do you do? If I had a bunch of these, I would be doing them on the Tapmatic up in the front part of the shop. All right. Oh yeah, no, it's like when I break a spring, because springs break, it's like a 10-second switch out. So any of the parts that, break, any of your failure points, I've made to where, they're really easy to switch out. But yeah, you're right. And that's some of the difficulty that, I run into is, as cool as, I think the cyberpunk aesthetic is, not everybody loves it. Which, whatever. So actually, I'm gonna Cerakote, the gun coating manufacturer. Their their outfit is like 5 miles to the north of my shop, and we're gonna do something together. They're gonna do up one of my hands. I actually sent them a text this afternoon. So I'm going to be Cerakoting it Armor Black, Tactical Gray, and Hunter Orange. Yeah, and then the pins, they have a product called Micro Slick, and that's what I'm going to have them do the pins in. Oh, totally. Well, and really, the mag aluminum doesn't really take anodizing that well because it's not a homogeneous product. These parts, even though they're relatively solid, are still pretty porous. Okay, so that goes like that. And that goes like this. Okay, so I started out life as precision sheet metal, and I did that for probably 10 years. And then the shop that I was working for, the guy that owned it, he was retiring. So then I bought my building that my shop's in. And then I started doing ornamental iron and structural steel, and I did that for most of the 2000s. I started my shop in 1996. And then in 2008, when we had the financial issues with the housing collapse, I went into doing automation and conveyors for candy making. And then that's also when I started doing interior stadium project managing for the Super Bowl. So I do that during the winter. And then I do the machine shop during the summer. Well, Cerakote is in White City, Oregon. That's where their main facility is. It's like on Avenue G in White City. I'll be doing a video. When they start doing my when they do my hand. Actually, they're going to do Brandon's, Chris's, and my hand all at the same time, and that'll be pretty cool. Oh, yeah. So Tualatin is. So I'm in Southern Oregon. I'm almost in California. I'm in Central Point. That's cool. So we have Anodex down here for anodizing, and they're a subsidiary of an antenna company called Scala Antennas. And they also do some powder coating, but they're mostly an anodization shop. That is super awesome. I want to say thanks again, Reed. That was awesome. You know, I mean, that just does not happen very often that somebody drops money like that. That is super cool. Thanks, man. So I will be making this out of aluminum tomorrow. Um, I thought I had ordered it, but evidently I didn't when I ordered all the parts from PCBWay. It So it can do two things. If you do with a metal salt bath, it can actually harden the surface of the aluminum. So what it does, the grain structure of aluminum is hexagonal, and the nitric acid, because they do a nitric acid bath on it, and under current, it basically micro etches into the surface of the aluminum, and then you heat it up, the aluminum swells, and then a metal salt is introduced into that, and that has the dye in it, and then when it's cooled down, that aluminum grain structure shrinks back down around it, capturing that salt molecule in there, basically making it more dense. Oh, that's cool. Yeah, there's a pile of science to it, because I mean, you can, depending upon the voltage, depending upon, they actually have to calculate the square inches, the square surface inches of, the amount of stuff that you're putting into the tank, because then that's going to adjust the voltage. Like if you have a million billion, square inches of aluminum, you need to up the voltage because it goes, volts per square inch. Totally different. So titanium actually forms an oxide. You don't actually add a dye to titanium. It's all done by voltage. So different voltages cause the titanium in basically the baking soda solution to form a different colored oxide. And those different oxides happen at different voltages. And again, you still have to calculate the square inches, but it works off of a wider array. It's like if you had, say, if you're doing, say, 10 volts per square foot, so that's 10 volts over 144 square inches. But you can adjust the color by the voltage, which is amazing. I mean, so it's like I've looked at having the fingers printed in titanium, and I would do it, out of the bougie being able to color them, myself. But what I'd be afraid of is the tiny holes that get tapped. So like on the metacarpal bases, you have two that are tapped at 256, and you have two that are tapped at 440. And then, on the splay linkage, you have a bunch of 172s that get tapped. And where the titanium would be SLS, you're going to end up with heat affected zones at the circles. Any of the holes would have heat affected zones around them. So that would be difficult at best. Yeah, it is. It's incredible, and it eats tooling. Whereas like this mag aluminum, and a lot of the parts that I end up machining are all out of 60 series and 70 series. Okay, so switching to fingertips. So I am doing color fab TPU on the Prusa XL. I've had super good luck with that. Let's see if I have. So, like this one, I did it out of 3 different color fab materials. They're all the same TPE, but I'm printing them at different temperatures, which gives me the different densities, which is awesome. And so far, I've got. So far, I get about 4 months out of a set of fingertips. Of course, it all depends on what you're doing. Like if I'm doing, a bunch of heavy work, say if I'm, doing plasma cutter stuff, then I don't get the longevity, that I'd get, say, if I was just doing just machining and turning dials. So I mean, like with your own fingers, if you're no, but I don't stop you from reverse engineering it, but I'm not going to give you my CAD. And the reason is because if I just give you my CAD, you're not going to make it a better design. You're just going to copy what I got. And like I said, the fingers are, they are such a small portion of the device. I mean, maybe when I'm dying from cancer, maybe part of my last hurrah, when I'm checking out from cancer, maybe I'll, GitHub the drawings, but right now I'm going to try to recoup some of that, 20,000 hours that I have into this project. Well, and I probably have more than 20,000 hours. I mean, honestly. Yeah, I have multiple myeloma. It's a hematological, so it's a blood cancer that eats your skeleton. I do chemo once a month. It's 9 hours. I do DDR, so that's Darzalex, dexamethasone, and Revlimid. And yesterday was actually 7 years post-transplant for me. Oh no, you got to figure, if I hadn't got sick, I wouldn't be doing this. So I mean, in a sick sort of way, cancer led me to doing this project. Because before I was doing automation and bracket fabrication and all that. So now it's, I deal with cancer, a couple days a month. Well, a week a month, 1 week. And then I try to ignore it for the rest of the time. Which sometimes I can do that. Sometimes I can't. Like what I said in that video, the video that I put up today, I got sick in February. Yeah. No, I was living at the hospital and all kinds of bad. It was a sack of suck. Yeah, so it's color fab. I'm using color fab. It's a little expensive, but it works really good. Yeah, it works really good. And then I also have some stuff from Recreus out of Spain. That stuff is like super squishy. And I'm playing around with that a little bit just to see, you know, how it works. But I think I'm going to be able to do some of it with the Recreus. So this is what Brandon's winder is going to look like. So, like I said, I'm going to machine this tomorrow out of aluminum. You know, primarily because plastic isn't strong enough. You know, here's the one for Chris. All right, so let's see what okay, so I need some just chain. I don't think I have any just chain. I mean, I do up front. Okay, so aluminum 3D printers. Like what? Like consumer grade aluminum 3D printers? I haven't seen anything that I would, but I'm having PCBWay and JLC do printing out of mag aluminum. Okay, I'm going to go get a length of chain and I'll be right back. Okay. So I haven't seen, you know, I've seen, you know, Ultimaker supposedly has this material that, you know, it's metal 3D printing that then you send out to be post-processed, you know, and sintered. And it's copper-based. But I haven't, it's really expensive. It's a BASF material. And it's like $300 a kilogram. You know, and then you still have to, you still have to pay for the reduction. You know, because it's a binder type material. I mean, I would love to try it out, but you know, it's the wrong type of material for what I'm doing. Right. You know, and that's why, you know, just having PCB way or JLC do it, um, you know, is actually pretty affordable. Even with the tariffs, it's so it's like I would try to have this printed in the US, but everybody that I've talked to wants larger quantities than what I'm doing for the hand project. Oh, actually, that has to go in. That has to loop in. That can't go on the outside. So, but like most of the AM stuff, you know, for metal, it's all stainless, titanium, you know, Inconel, more industrial metal. There actually aren't a lot of people that are doing the mag aluminum. And I think that's because, you know, it doesn't have the strength of machined manufactured aluminum. Oops. Shoot. Oh yeah, no, I mean you could do a decorative um you know, like a decorative board type design, you know, for just an aesthetic piece. But, you know, that's extra weight that you're packing around. You know, that's ultimately what it comes down to, you know, how much extra weight are you willing to pack around for, you know, for the aesthetic? And so I tried a set of fingers out of stainless a million years ago, and they were so the wrong weight. I mean, they were just way too heavy. So, and the mag aluminum is night gifter. The mag aluminum is like half the weight of the stainless, or yeah, it's half the weight of the stainless. Sweet. All right. So that is essentially the chain lace up for Brandon's thing. And it should work pretty good. I hope. We'll see. So this ends up going to the distal driver of, oh, it goes to the cross link, and then I machined some magnesium, on and off, just as job shop. But as far as for parts for the project, no. I would just stick with aluminum just because it's so easy to work with. It's easy to tap. It isn't super gummy. It's just easier to work with. Yeah, so what I end up running into is the limitations on the printing process on this. So you need at least 1.5 millimeters thickness for a single wall to be SLS printed. That's just as skinny as what they do. So like on the proximal 1s to proximal 2s, so you have a 1/16 to 1/16, 1/16, 1/16, plus 1/4 inch for the spring and the chain, and that ends up at 1/2 inch is as narrow as you can get it to be on the finger, which is then 5/8 of an inch on the metacarpal base, because you're stacking up layers. So right now I have it as small as what this design will allow me to do. Right? Exactly. Yeah, like these, these are divide by twos for this linkage setup, and what that's doing is it's grabbing by the center of it and dividing the slop in half for each time that it's used. But because the distances are because the throw distances are so short, any slop that you end up having. So this is a keter finger that is keter top and bottom. And what ends up happening is through it wearing over the year, of a bunch of splay, it ends up widening the opening on the keter, which then allows for more, play within the metacarpal base to the mounting rail. So hopefully with changing this design to be in cylinders as opposed to a keter, you're going to have more of that forward support to where it doesn't end up allowing for that play. So I mean, there's a bunch of design aspect to it that has taken all kinds of time to get it to be right. Yeah. I mean, it's like, I mean, the neat thing about the splay linkage on this is, you know, all of the splay linkage is bolted onto the metacarpal bases. So if I decide to change something up with how the linkages work and all that, you know, I can change that and use the same metacarpal bases and iterate from there. Whereas if they were integrated, because they used to be integrated into the metacarpal bases, you know, you really can't change anything. So, you know, these bolt into the mounting rails, and then the splay linkage bolts onto these, and then that's what gives you the splay motion. You know, it's a separate piece. So it allows you to, you know, iterate some. Hope that helps. You know, it lets it be a little bit more modular than what you'd think it would be. Well, like, what do you want the exoskeleton to do? I mean, you know, you got to have a, I want it to do this first before you go and just start randomly designing. So, like, for your exoskeleton, what do you want it to do? Is it you want it to move fast? Or you want it to pick up heavy things? Or it's just supposed to be some BattleBot thing? Or what? Oh, and DOD is all kinds of evil. You know, they say they aren't, but they are. You know, they're into strapping a gun onto anything. Can't see if this is already threaded. Nope, not threaded. I do feel phantom pain and phantom sensation. When I was at Detroit Rapid TCT, I actually did a video of, I was able to, with my mental fingers, I was able to feel, I had grabbed a Diet Pepsi out of the cooler and I was able to feel it. It was the craziest thing. Right, but see, you'd be better off just building a robot and let the fleshy human be a zillion miles away, you know, controlling it from a cellular network. You know, then you aren't constrained with having fleshy bits, you know, get tired or, you know, grow a conscience or anything. Yeah, I mean, if you're going to go, you know, the whole Cyberdyne thing, you know, let those things be autonomous and yeah, I usually do lives from like 6 o'clock on Pacific time. And lately it's just been, I'm building this hand for a guy, and he ends up showing up on the live sometimes. I don't think he's on right now. Is Brandon on? Or did Brandon go to bed? I think Brandon has gone to bed. Yeah, no, it's cool. You know, and still being able to do all this stuff. You know, it's pretty cool. You know, it's like I still run a machine shop. I still do welding. Still, you know, it's like I just finished up some stuff for a concert. Um, some hex hoops for a geodesic dome. You know, I still do like the Olympics and Super Bowl and all kinds of stuff. Oh yeah, no, I am still working on new things. You know, the thing is where I'm a user, I'm always thinking about what needs to be, you know, what needs to be changed on the design to make it better. You know, be that, you know, more robust, different features, different aesthetics. Um, you know, I don't think I'll ever truly be done with this. I mean, I'll reach a place to where I'm not, you know, making a new design every, you know, right now it seems to be about I'll wear a device for a year and then by that time, no, it's just me. I've been self-employed sole proprietor for 30 years. So I wouldn't think of doing it any other way. Um, I mean, occasionally I'll bring in somebody to give me a hand for something for a couple days, but I always try to just keep the jobs, you know, with enough timeline to where it's just me and I can manage. And you know, and that's worked. That's worked for the last forever. So these are metacarpal bases. This is for Brandon's 3-finger device. Um, so my hand weighs 1 kilogram, so 2 pounds. And that seems to be I could make it a little bit lighter, but 2 pounds seems to be about the right weight. Uh, you know, it feels like the right weight. Um, anything less than that, and it feels just too light. And you know what I'll end up doing is I'll end up putting a watch on it or something on the forearm cuff, and then that actually balances out the weight, along with gives it some class. Okay, so I'm going to go till 10 o'clock, and then I have to get home because I have to, well, I have to do this again tomorrow. So if we have any questions, we got 24 more minutes. So it sounds funny. I use Dawn dish soap and I wash it in the sink. If it's something that's like super super gritty, I'll use brake clean, and then I use a silicone dry lube for the chains and stuff. But I'm hoping when I do the Cerakote that the Cerakote actually keeps it from attracting dirt. I mean, at least that's the idea, that it's gonna keep it from getting dirty. So the thing about the extras, like say if you were to put, an out front knife or something on there, uh, it ends up just being extra weight. Say if you were to, you know, incorporate like a switchblade or something there, it's, I mean, like this weighs probably a third of a pound. So you're going to end up making your hand weigh a third of a pound more just for making it weigh more. So, yeah, I try not to have too many extras of anything. I'm looking for my little reamer that reams the metacarpal bases. There it is. So I ended up making this piece of tool and die. It's well, exactly. No, so they're actually all afraid of it for ADA. Uh, I don't take it off when I go through the airport or anything. Uh, they scan it and they wipe it down. They wipe it down for explosives, but aside from that, it's nothing. And if, like, say if I'm going, like when I went overseas last year, um, I brought a backup hand with me just in case something happened to my number one hand. And they scrutinize the backup hand pretty well, but for the most part they don't do anything for if you're wearing it. um so I have 16 of them on the wall, all different versions or iterations, or all different, just all different, doing something. Well, I mean, you got to figure I've been doing YouTube on this project for what, 5 or 6 years now. I kind of feel like Winter Garden a little bit, to where he's always trying to make the perfect something. Sometimes I feel like I'm doing that too. I like the one that I'm wearing right now. That's a pretty good one. I like my other forearm cuff, though, because it has a watch on it. But the other one's forearm cuff ends up being a little bit bitey. Why would you do double pull, double throw? Why not just go digital with it and go RS-232 and go with hybrid servo steppers? So I would do the arms. Let me see. Let me look it up real quick. North Korea had, there was an outfit out of North Korea that was doing an upper body. Oh, what is it? It was all cable driven, and it was pretty awesome. Yeah, and they were doing a rolling contact joint. Okay, if you were to look up LIMS, actually LIMS 2 under Ambidex, AMBIDEX, that is a super cool arm design. Well, I am in America, so that's going to be somewhat different. That's going to be somewhat problematic. So here is what Ambidex has come up with their LIMS program. And it has the effector end uh, is all effector. They have all the motors up in the shoulder joints. And I mean, it's super fast. It doesn't have hardly any inertia in the arms. Oh, it is. And it's all rolling contact for the joints. And super compliant. Yeah, so look up Ambidex LIMS2. And that's pretty awesome. I mean, that's probably the most awesome that I've seen for, robot arm type things. And it's super fast. Oh, it is, because it has all the weight of the motors just up in the shoulders. Okay, so you say robot chefs, they actually did a pair of those arms up mounted, mounted on the ceiling, and they were doing that as cooking robots, and it was on two linear tracks to where the arms would actually move and articulate, and it would work the entire kitchen. Pretty cool. But I mean, with that type of technology, you have to have a functional, usable, this is what I'm doing it for. Rather than Okay, I'm back. That was my wife. I have to go home. Playtime is over. So I'll try to do it again tomorrow night. I want to thank everybody that has stopped by to see me. That's been awesome. I want to thank uh, everybody that contributed to the fun today. It's super awesome. Okay, yeah, so probably like 6 o'clock, maybe 5 o'clock tomorrow, Pacific time. All right. All right. Thanks, guys. See you tomorrow.